Okay, the remainder of this lesson on Introduction to Trig Identities is to work through about a half a dozen examples here. These are all taken from the next quiz prep exercise. So I'll show you how to work each of these out, and I'll also explain a little bit about what Alex is looking for when you do those online. So the first thing we want to do is to simplify this fraction, sine of x times the secant of x divided by the tangent of x. A good rule of thumb is this. When you have a lot of things to simplify, they're already involving a fraction, you can often make progress by switching to sines and cosines. And by that I mean this. The sine of x, that already is a sine or a cosine, so we leave that alone. But the secant is the same as 1 over the cosine. So sine of x, if I wanted to write this all out, I suppose I could do something like this. Then the secant is 1 over cosine. And this one down here, tangent, this is sine over cosine. But we're dividing by that, so it's the reciprocal of that. Instead of sine up here and cosine down here, it's sine down here and cosine up here. So we're just switching to sine over cosine, and the thing that gives me the right to do this is the ratio identities. All right, the next thing I would do is put as many things together and cancel as many things out as I can. Well, you can see that I've got a sine in the numerator here and a sine in the denominator here. Those would cancel out. A cosine here and a cosine here cancel out. Well, all that's left is 1 over 1, which is equal to 1. That's a serious simplification, right? Sine of x, secant of x over tangent of x is just equal to 1. Now, the thing that gives me the right to do this is what Alex will want you to say, that you are using algebra. And on these kind of questions where you have to specify a kind of a justification, all they're either asking you to do is to say algebra or to say from, I want my other handout here, from which category you're taking the identities that you're using. So in that first one, I was using the reciprocal identities to go from here to here. That's why. Or I was using the ratio identities, I should say. I converted this tangent to sine over cosine. Actually, I suppose I was using both, wasn't I? Because here I used the secant, turning that to 1 over cosine. That's a reciprocal identity. So I have kind of a multiple step here. Now, I said I would say a little bit about the way Alex wants you to do this. Alex will probably not like it if you go from here to here. And the reason it won't like it is because I'm actually using two different kind of identities, right? To convert that tangent to sine over cosine, I'm using a ratio identity. To convert the secant to 1 over cosine, I'm using a reciprocal identity. Well, I can only give one reason at a time on Alex. So they would want you to take it in 2 steps, probably something like you go from here to here, converting that secant to 1 over cosine and leaving a tangent in the denominator. Then you take another step where you convert that tangent to sine over cosine, and then the algebra step where you cancel things out and get down to 1. But it will be essentially the same proof, whether you're taking 1 or 2 steps to do it. So that's the first example. The second one I'd like to do is this: simplify cosecant square x minus 1 times the sine of x. Okay, on something like this, once again, the way I would approach this would be probably to convert to sines and cosines and see what we can get to clean up. The cosecant is the same as 1 over the sine. So cosecant square x is 1 over sine square. So that would be an option here. And it might be a good one, but keep in mind that there isn't a real easy way to put these together into a single term, unless we can use one of our Pythagorean identities. So let's take a look at that. Cosecant square x minus 1. If I took this one right here and I took this 1 and put it on the other side, cosecant square x minus 1 is the same as cotangent squared. So I could switch that one on the first step. Cosecant squared minus 1 is the same as cotangent squared. And then times the sine. All right, the next, whoops, sine of x, not just sine. Now the next step, cotangent, is cosine of x over sine of x. But that's cotangent squared, so these are squared as well. Now, I should probably put in my reason on this one right here. What I did is I used the Pythagorean identity to convert cosine squared x minus 1 to cotangent squared. All right, then cotangent squared converts to cosine squared x over sine squared x, and I'm going to multiply that by sine of x. And so in this case, I use the ratio identities. Then this sign will cancel with that one, so I've got cosine square x on the top, and I've got sine of x on the bottom. Okay, and this is a step of algebra here. All right, now what's left is can be simplified a little bit. The cosine over the sine is a cotangent, and then I also have a cosine here. So this rather lengthy thing here, cosine squared x minus 1 times sine of x, is the same as cotangent of x times the cosine of x. This is generally considered simpler because this one has two factors, as does this, but one of the factors here has two terms. So we've reduced the complexity a little bit. Now, another possible route here would have been to multiply the sine into this in the first case. You could do that, but it turns out to be no easier and probably in fact a little bit worse. So maybe I should show you that, because after all you might try it, right? Cosecant squared is 1 over sine squared. So another option is to convert this to 1 over sine squared x, subtract 1, and the whole thing is multiplied by the sine of x. And we're trying to get back to this again. Okay, so if I take sine of x times 1 over sine squared of x, I'll get 1 over sine of x. And sine of x times minus 1 is minus sine of x. Okay, now, can I put these two pieces together? Well, I can. If I say that this one currently has a denominator of 1, I can multiply it up and down by sine of x. To get a common denominator. Then I can put these together. Now I have a common denominator, sine of x, 1 minus sine squared of x. Okay, now that is this identity in disguise. Sine squared x plus cosine squared x is equal to 1, so that means 1 minus sine squared x is cosine squared x. So I have cosine squared x over sine of x, and if you wanted to split it into two factors, we could say that's the cosine of x over the sine of x. and then I've got another factor of cosine of x left over. And that turns out to be what I had before. Cosine over sine is cotangent of x times the cosine of x. And this are the same, so you can do it both ways. I think maybe that one is a little less painful, but neither one of them is probably all that pretty. Okay, let's take the third one, and then I will continue the rest of these on the next video. So the third one, we're supposed to prove that the cosecant of x minus cotangent of x cosine of x is the same as the sine of x. So let's copy that out. And we would like to write this as a proof. Now, how do you write a proof? Well, generally speaking, what we're going to do is pretty much exactly what we were doing before with simplification. It's just that we're going to start an equation that starts with this, and we're going to have a string of equalities, and we're going to end up with that. And each step along the way will be, we could give a reason for it. So I'm going to start here, cosecant of x minus cotangent of x, cosine of x. And what I'm going to do is actually write a sequence of equalities, and I'll try to make the steps small enough so that I can give an individual reason for each one. All right, cosecant of x, that is 1 over the sine. And minus cotangent of x, well, I'm probably going to have to, I could convert that right now, but that would then be a different reason. So I'm just going to do convert that first one right now, and that's reciprocal identities. And I'll just abbreviate that. Okay, now this, which is equal to this, will be equal to the next step. 1 over sine of x minus cotangent is cosine of x over sine of x. And I've also got a cosine of x sitting here. And that is using a ratio identity. Namely, the cotangent is cosine of x over sine of x. All right, next, I have essentially got two fractions here, and they already have a common denominator. So let's just write them together. It's 1 minus cosine squared over sine of x. And then, whoops, I don't want to go too fast. This is a step of algebra. Then, 1 minus cosine squared is sine squared. That is a Pythagorean identity. And finally, the square of the sine of x divided by the sine of x is sine of x. And so there we have it. We start with this side. We work only on that, taking legal steps of algebra and using other trig identities, and we end up at this one. So we have now proved this identity right here. Okay, that's the first 3 of the 6, and I will show you the second 3 in the next video.